So thank you for joining us. I'm just going to ask everybody to put yourselves on mute so when Anjali is talking, we don't accidentally interrupt her. My name is Carolyn Klauba. I am the Stewardship Program Coordinator for the Sourland Conservancy. The Sourland Conservancy is a nonprofit organization dedicated to protecting, promoting, and preserving the Sourland Mountain region. One of the ways we do that is through stewardship. And stream monitoring is a really important part of stewardship. Having clean water is important for everybody, not just for people, but for our environment. And we take it really seriously. We want to work with our community to learn how to conduct stream monitoring. So today is part one of a two-part series. And part one is going to be taught by Anjali Thakker. She is a New Jersey Watershed Ambassador for the Watershed Management Area 11. Anjali graduated from the College of New Jersey in 2019. And the Watershed Ambassador Program employs people to go and conduct stream monitoring throughout the state of New Jersey, and each watershed ambassador is assigned to a different region, and Anjali can talk more about that. So I really appreciate her coming and doing this presentation for us. And with that, I'm going to put myself on mute, and if you have any questions while she's talking, put them in the chat on the Google Hangout, and she's going to address them later on, and she's a little interactive game for us to do at the end. So thank you so much, Anjali, and I'm turning it over to you. You're on mute.
Sorry, muted. Thank you so much. Quickly share my screen. Sorry. Can everyone see that?
Yes. Yeah, you're good.
Awesome. Okay. So good afternoon, everyone. Thank you so much for joining me this afternoon to learn about stream assessments. Throughout this presentation, I'm going to be focusing specifically on rocky bottom streams because I believe most of the streams in the Sourland Mountain region are rocky bottom streams. The presentation is going to be divided into 3 different parts. So first, I will quickly go over the protocol for our habitat assessments. Then I will go over the protocol for biological assessments and introduce you all to some of the macroinvertebrates that you might find in your streams. And finally, we'll do a little activity where you all will be able to identify different macroinvertebrates using a dichotomous key. So before we get started, I'll quickly introduce myself again. Caroline did a great job introducing me. Like she said, my name is Anjali, and I'm a member of the AmeriCorps Watershed Ambassador Program. So this program places one ambassador at a different host agency in each of New Jersey's 20 different watershed management areas. I serve in Watershed Management Area 11, which is also known as the Central Delaware Watershed. Part of the Sourland Mountain region is located in my watershed, WMA 11, but there are also parts of the region located in WMA 10 and WMA 8. So on your screen, you'll see a picture of me and my very stylish pair of waders. My favorite part of my term of service has actually been conducting biological and habitat assessments in streams all across my watershed because they're like these great little treasure hunts. Every time I assess a stream, I always find different critters and learn something new about my local environment. So this is one of my favorite presentations to give, and I hope you all are as excited as I am to get right into it. So benthic macroinvertebrates are an important component of both habitat and biological assessments. So it's important that we know what they are. So we can break down this term benthic macroinvertebrate into 3 different parts. Benthic means bottom. Macro means large enough to be seen with the naked eye. And invertebrate means without a backbone. So if you put all of these parts together, a benthic macroinvertebrate is an organism that does not have a backbone, who lives at the bottom of a stream and is large enough to be seen with the naked eye. So benthic macroinvertebrates, or macros for short, are important to stream assessments because they are bioindicators that help us to assess the health of a water body. So some macros are pollution intolerant, meaning that they will not be able to survive in water that contains even a small amount of pollution. Therefore, if we find a majority of pollution intolerant macros in a stream, then that indicates that the stream is healthy. Macros also require an overall healthy habitat to survive. Therefore, the purpose of our habitat assessment is to determine whether or not there is suitable habitat for macroinvertebrates in a water body. One component of this assessment consists of ranking the stream on several different parameters, which I'll be discussing in the next couple of slides. And the other component of this assessment consists of taking depth, width, and velocity measurements. So in this picture, you can see an ambassador taking a velocity measurement using our very high-tech scientific instrument called a rubber ducky. So what you see on your screen is a copy of the first side of the sheet we use to rank the different habitat parameters. We rank each parameter on a scale from 0 to 20, and depending on the ranking, each parameter will receive a score of optimal, suboptimal, marginal, or poor. So for the sake of time, I'm not going to go over every parameter, but I would like to point out two, which are epifaunal substrate and embeddedness. So epifaunal substrate describes organic matter that might fall into a stream, such as logs and sticks. And embeddedness describes how much fine sediment is present between larger pieces of cobble and rock. Macros love to cling onto organic matter and burrow themselves under bits of rock. Therefore, the more organic matter and cobble that is in the stream, the more habitat that is available to macros, and the higher the stream's habitat score will be. So this is the second side of the sheet, where we finish ranking all of those parameters, and then we add up the final habitat score. We then use the chart at the bottom right of the sheet to translate the numerical score into an overall optimal, suboptimal, marginal, or poor habitat score. So these two pictures show what an optimal habitat for a rocky bottom stream might look like. You can notice in these pictures a lot of cobble, boulders, and leaf packs, which macroinvertebrates would like to cling on to. The water is also not turbid, which means that it's clear. The water also reaches both stream banks, and there's no signs of a lot of erosion on either of the banks. And the banks are also covered in vegetation, which again provides habitat for our macroinvertebrates and also prevents pollution from entering our stream. So on the other end of the spectrum, these pictures show what a poor habitat might look like. So both of these streams are channelized, meaning that the banks of the stream have been altered by humans. There's also almost no vegetation on the banks. And then in the left picture in particular, you can notice that there's quite a bit of fine sediment between the cobble. And I think there's even a little bit of litter in the water. And both of these streams would be at great risk of being affected by non-point source pollution in the form of fertilizers from lawns, litter from pedestrians or residences, and car oil from the roads. So this combination of lack of suitable habitat and risk of pollution make these streams places where macros are unlikely to survive and thrive. So before we move on to biological assessments, does anyone have any questions about anything we covered so far?
Nope, I think you're good.
Awesome. Keep moving. So now we'll be discussing biological assessments, which allow us to determine whether or not a stream has been impacted by pollution. So during this type of assessment, we collect a sample of 100 macroinvertebrates and then identify them. Once they are identified, we sort them into categories based on their level of pollution tolerance. So the chart you see on your screen shows you the 3 categories that we use and what macroinvertebrates fall into these categories. So pollution intolerant macros, such as the mayfly or the stonefly, cannot survive in water that contains even a little bit of pollution. Pollution sensitive macros, like the net spitting caddisfly or the damselfly, can survive in water that contains a little bit of pollution, but not a lot of pollution. And finally, pollution intolerant macros, such as the leech or the midgefly, can survive in water that has quite a bit of pollution. So after sorting the macroinvertebrates, we use an equation similar to a weighted mean to calculate how impacted the stream is by pollution. We obviously want to find a lot of pollution intolerant macros because that means that the stream is not impaired. However, if we find some pollution tolerant macros along with our pollution intolerant macros, that does not necessarily mean that the stream is impaired. So the most important thing we look for overall is actually a diverse sample of macros. So, for example, if we only find mayflies, which are pollution intolerant, in our sample and no other types of macroinvertebrates, then this means that the stream might still be stressed. It may just be that pollution is not causing the issue. So how do we actually collect macros in our rocky bottom streams? So first we want to identify a 100-foot stretch within the stream, within which we'll be taking our sample, and then we're going to walk to the farthest point downstream within that stretch. We then locate a riffle, which is an area where the water is bubbling over a patch of rocks and cobble. You can see what a riffle looks like on your screen. Then we take our D-net and place it flat against the bottom of the stream to ensure that none of the macros that we're trying to collect float under the net. You might have to move some of the rocks out of the way to do this. And then we pick up any rocks that are in front of our net and rub them with our hands. As I mentioned earlier, macros love to cling to the underside of rocks. So rubbing them ensures that we don't miss anything. And finally, you're going to want to take your foot and disturb the sediment you just exposed to shake any other critters into your net. So we'll repeat this process 9 other times to give us 10 scoops total. And we usually take about 3 to 4 scoops in 3 different riffles. So these pictures show what it looks like when we're conducting our biological assessment. So in the picture on the left, you can see someone rubbing the rocks in front of their net before then moving them aside. And then in the picture on your right, you can see someone else disturbing the sediment with their foot. And then once we're done with our assessment, it is really, really important to decontaminate anything that touched the water. So that includes all of the gear that we used and our waders. And this helps to prevent the spread of invasive species such as Didymo. So does anyone have any questions about the biological assessment protocol?
So are these macros hard to tell the difference? Like when you're out in the field, do you bring any tools with you to help you identify between the different species?
Yeah, So it kind of depends. Obviously, the larger macros are easier to identify, but we'll usually bring magnifying glasses to help us identify some of the smaller macros. We also bring ice cube trays to help us sort the macros. That just keeps everything organized. And then we also bring things like tweezers, spoons, even pipettes, and that just helps us to separate the macros from the entire sample.
So we did get another question, and the question is, if there's no riffle in your 100-foot section, how do you know where to sample?
That's a great question. So if there are no riffles, I think that would indicate that there's an issue in the stream. And it also depends on what stream you're working in. So the rocky bottom, it usually has riffles. The sandy bottom, on the other hand, which is located in different parts of the state, riffles aren't present. So there's a different procedure for that. And essentially what you'll do is you'll take your D-net and actually disturb the vegetation that's on the stream banks, because that's where the macros are clinging onto. So depending on the stream, it's a different procedure.
Okay, I got another question. In terms of cleanliness, how would you say the Sourland Mountains are? Have you worked in any particular places that are more highly polluted, or is it generally better quality? Or in your region in general, is there some places that are better than others?
Yeah, that's a great question. I would say a majority of the streams that I've assessed in my own watershed have been pretty optimal, both the habitat and biological assessments. I would generally say that streams in more urban areas or more developed areas tend to be a little more polluted, but that's just because there's more non-point source pollution in the area from residences, businesses, roads, all of that. But I think the Sourland Mountain region, because I believe it's a preserved space, typically pretty healthy.
Great, thank you.
Awesome. So now we can get into my favorite part, which is going over all of the cool macroinvertebrates that we can find in our stream. So to identify the macros, we look at their body parts, such as their head, the thorax, the abdomen, legs, tails, prolegs, and gills. And these characteristics will vary by each macroinvertebrate, which allows us to decide which macro is which. So we'll start off with our pollution intolerant macroinvertebrates. So again, just to reiterate, these macroinvertebrates cannot survive in water that even has a little bit of pollution. So first we have our mayfly, which is a common one that I find quite a bit. These guys have 3 pairs of jointed legs, each with a single terminal claw, which helps them grasp onto any organic matter or rocks. They also have obvious lateral abdominal gills that can look leaf-like, feathery, or spiky. And they usually have 3 tails. Sometimes they can be missing a tail, so they might have 2, but typically if something has 3 tails, it's a mayfly. Next, we have the stonefly. This is one of my favorite macroinvertebrates because they have that beautiful pattern on their back. They also have 3 pairs of jointed legs, this time with 2 terminal claws. They don't have any abdominal gills, but they have these tuft-like gills in between their legs on their thorax. So we refer to those as the hairy armpits. And stoneflies have 2 tails instead of 3 tails, and their antennae are usually very long. So next we have case-building caddisflies. These guys are usually pretty easy to identify because they live in a little portable case. So they build this case out of anything that they can find in the stream. It could be wood, little bits of rock, leaves even I've seen. There's actually this really interesting study where scientists put a case-building caddisfly in a tub with precious gems and gold, and the caddisfly actually made a case out of all of those precious metals and gems, which is pretty cool. If it's not in its case, it's going to have 3 pairs of jointed legs. It's also going to have a hardened head with 1 to 3 thoracic segments. See there? And it will have a pair of hook-bearing prolegs at the end of its abdomen. Now we have the hellgrammite. I think this is one of the scariest macroinvertebrates we could find in the stream because they will bite you. They have 3 pairs of jointed legs, and their abdomen has 8 pairs of lateral tactile filaments or gill tufts. So these spiny things you see on its abdomen are filaments, not legs. And then a defining characteristic of the hellgrammite are its really large, powerful mandibles that it uses to catch its prey and also to sometimes pinch your finger if you're not careful. And then its abdomen ends in a pair of short, spiny prolegs, and each of those prolegs has a pair of hooks or claws. Next, we have the watersnipe fly. Out of all the assessments I've done, I've actually never found a watersnipe fly, so they're pretty elusive. Unlike the other macroinvertebrates that we've discussed, these have a soft body. And they also have a pair of abdominal prolegs. Their body is tapered at the head, so it comes to a neat little point. And then at the tail end, it has 2 long filaments that are often hairy. Next, we have the riffle beetle. So this macroinvertebrate actually spends its entire lifespan underwater. So we could find either the larval form of the beetle or the adult form. So the larval form has a hardened, stiff body and head. It's also very dark in color, and it has 3 pairs of jointed legs. But because the larval form can sometimes be super tiny, it can be difficult to see the legs. And then the adult form also has a very hard body and is dark in color and has those 3 pairs of jointed legs, but now it looks like a beetle. So the adult form is pretty easy to identify. Next, we have a water penny. Pretty straightforward. It just looks like a small brown circle, and it likes to stick and blend into rocks. So again, this is why it's important during or while we're collecting the macroinvertebrates to rub down the rock so that we're not missing any of our water pennies. And then finally, we have the gilled snail. And the way to identify if a snail is gilled is to make sure that the tip of the shell is facing upward. And then if the shell opens up on the right, it's a gilled snail. Does anyone have any questions about our pollution intolerant macros?
So there are a few questions. Somebody wants to know, how small are these macros?
Yeah, so that it varies depending on the macro. Some of them can be super, super tiny, like the riffle beetle larva. So those are the ones where you might have to use a magnifying glass to be able to see it a little bit better. But something like the stonefly could be as large as maybe your thumb. So it really depends, but none of them are massive.
And are water snipes rare, or are they just really shy?
That is a really good question. I'm not sure if they're rare. It might also depend on where in New Jersey you're at. So they might not be as prevalent in WMA 11 as they are in some other areas. But I'm not sure if they're actually rare. It's a really good question.
And which kind of snail opens on the left?
That would be a lung snail. So the lung snail is actually pollution tolerant. So I'll be getting to that a little bit later in the presentation.
Oh, great. Thank you.
Awesome. Thanks for your questions. So now we're going to be moving on to the pollution-sensitive macroinvertebrates. And just to reiterate again, these are the macroinvertebrates that can survive in water that has some pollution, but not a lot of pollution. So first we have the net-spinning caddisfly, which is a little bit different from our case-building caddisfly. It has a hardened head, but it's always going to have 3 thoracic segments. It also has those 3 pairs of jointed legs. And in the side view, it looks strongly curved. So it kind of looks like a comma. And really important, it has these bushy tufts of gills on its abdomen. So the case-building caddisfly, if you find one without its case, it will never have these bushy gills. It's only on the net-spinning caddisfly. And then it also has these prolegs at the end of its abdomen, and it will usually have tufts there as well. So next we have the alderfly. Again, those 3 pairs of jointed legs. Like the hellgrammite, it has lateral filaments or gills on its abdomen. So those spiny things on its abdomen are not legs, they are gills. Again, like the hellgrammite, it's got, it's got some powerful mandibles, not quite as large, so these tend not to bite you, but they're still pretty powerful. And the abdomen ends in a single long terminal filament. It's a little bit difficult to see in the picture here, but essentially it looks like it has a spike or a feather coming out of the end of its abdomen. Next, we have a damselfly. It has 3 pairs of jointed legs, each with 2 terminal claws. It has large eyes and a very skinny, slender body. It doesn't have any abdominal gills, but it has these 3 tails at the end of its abdomen, which are actually its gills, and they often look very paddle-like. And unlike the stonefly, the damselfly has pretty short antennae. And the really cool thing about the damselfly is it has a distinctive scooping mouth part for prey capture. So if you were to look on the underside of a damselfly's head, it has something that looks like a mask located there, and this mask can actually extend out in front of its body and grab little insects for the damselfly to eat. Next, we have our dragonfly. Again, 3 pairs of jointed legs with those 2 terminal claws. Like the damselfly, it also has really large eyes, but its body is more stout. So its abdomen is a little bit more rounded and short. It doesn't have any external gills or tails, but some of them might have spikes at the end of their abdomen. So here you can see the abdomen is a little more bulbous at the end, have those spikes. And like the damselfly, it also has that scooping mouth part for prey capture. Next, we have the cranefly. This is another one of my favorites. So it looks caterpillar-like. Some might describe it as looking juicy. It has these fleshy finger-like appendages at its posterior end, and it might also have fleshy prolegs or creeping welts on its underside, and that helps it to move across the bottom of the stream. Next, we have the sow bug, and unlike all of the other macroinvertebrates that we've talked about so far, the sow bug is not an insect, it's actually a crustacean. So it spends its entire life cycle underwater, and the baby form looks just like the adult form. You can tell the macroinvertebrate is a sow bug if it's flattened vertically, so it's flattened from top to bottom, and the last plate on its abdomen is enlarged. Next, we have the scud, which, like the sow bug, is also a crustacean. It looks like a little shrimp, and it's flattened horizontally, so it's flattened left to right, and it actually swims on its side because of that reason. Then we have a crayfish. Some of you might have seen this macroinvertebrate before. Really easy to identify because it just looks like a tiny lobster. So do we have any questions about our pollution-sensitive macroinvertebrates?
One question is, sow bugs look like a kind of isopod roly-poly. Are they just similar in evolution to each other, or are they related?
Yeah, that's an awesome observation. I think they might be related because the aquatic sow bug is a crustacean, and pill bugs are actually terrestrial crustaceans. So there might be some relationship there.
Great, thanks.
Awesome. Okay, so our final category is our pollution-tolerant macroinvertebrates. And these are the macros that can survive in water that has quite a bit of pollution. So they're very hardy. So first, we'll start out with our midgeflies. These are very, very small larvae with a conspicuous hardened head. They have very small posterior and anterior prolegs, and they're usually a light cream color or a very bright red color. Next, we have black flies. This is the larval version of, the black fly that can kind of annoy us in the summertime. The larvae are bowling pin shaped, so the end of their abdomen is pretty bulbous. They adhere to substrate with the tip of their abdomen. This spring, right before we had to stay inside due to COVID, I was doing an assessment in Fiddler's Creek, I believe, and the rocks at the bottom of the lake actually looked black because they were just covered with these black fly larvae, which is pretty cool. They also have these brush-like mouth parts and a single proleg directly under their head. And these larvae are really, really small, so sometimes it can be difficult to see the mouth parts and the proleg. This is when you might have to use a magnifying glass to get a better look. And now we have our lung snail. So as I mentioned earlier, when you take the snail and put the top of the shell facing up and it opens up on the left, then it's a lung snail. So a good way to remember it is left-lunged, 2 L's. And then all other snails are also lunged. Next, we have our leech. It looks like a thick worm, and it's very segmented, so it can stretch its body out. And it has these sucking mouth parts, which it uses to attach to its prey and suck blood. And then finally, we have our aquatic worm. Super easy to identify. It just looks like a worm. So any questions before we move on to the activity?
I think we're good. Thanks.
Awesome. All Great, so now we're going to do a little activity where you all will get to identify some macroinvertebrates using our dichotomous key. So just in case no one has used this type of key before, I can walk you all through our first example here. So we always want to start at the top of our dichotomous key. So the macroinvertebrate that you see on the top right of your screen, does it have a shell or no shell? Maybe you can type your answers in the chat box.
No shell.
No shell, perfect. Start moving down. Does it have legs or no legs?
No legs.
No legs, perfect. So now we have these three options. We're looking at macroinvertebrates, so we're just going to ignore this microscopic option because we wouldn't collect anything like that during our assessments. So is it worm-like, or does it have tentacles, brushes, or tails?
Brushes and tails.
Yeah, perfect. So now we're looking at all of these guys over here. Anyone want to take a guess which one it might be?
Don't be shy. Okay, one person says crane fly, one person says black fly larva.
Not quite. So it does look very similar to a crane fly, but the crane fly doesn't have those two little filaments at the end of its body. And the black fly larvae are considerably smaller, and they have that bowling pin shape, which we don't see here.
Water snipe?
Yeah, the water snipe. Awesome.
Yay!
So again, you can identify the water snipe because of those two little filaments at its end. And it's a little tricky with this picture, so I apologize for that. But you can see here, it kind of has that tapered point at its head. So that's how we know it's the water snipe fly. So move on to the next one. I'm going to let you all go through this one by yourself. Maybe give you about a minute. So 143.
All right, so we have a couple of guesses? Flatworm, crane fly, or green fly larva?
Yeah, so whoever guessed crane fly, you are correct. So we can tell it's the crane fly larva because it's got that juicy caterpillar-like body. And it's also got those tentacles at its posterior end. Awesome.
Nice.
Breezing through. So give you another minute for this next one.
I think you're stumping people on this one. It's a pretty scary looking macro with some big pincers. All right. So some people guessed Hellgrammite.
Yes, exactly. So as you said, we can identify the Hellgrammite because it's got those big mandibles. It's a little bit hard to see in the picture, but you can also see those spines that are tucked in on its abdomen. So, give another minute for this one.
All right, you got 3 people saying stonefly.
Very nice, perfect. So we can tell it's a stonefly because it's got these 2 tails. It would also have gills in between its legs. Remember those hairy armpits? A little bit difficult to see in this picture. And a lot of stoneflies have that really beautiful sort of brown and yellow pattern on their backs. Not all of them do, but if you do see that pattern, it's probably a stonefly. So I think we have one more. Oh, I think we have 2 more. Let's give you another minute for this one.
People were quick on this one. Everybody says crayfish.
Yes, perfect. So this one's pretty easy to identify. Crayfish just looks like a tiny lobster. And this one is our last one.
Some very enthusiastic caddisflies.
We know which type of caddisfly?
Case caddis. Case building caddis.
Yeah, case building caddisfly. Awesome. Again, another one that's pretty easy to identify if it's in its case. So So does anyone have any questions about anything we covered today, about the activity?
Where can people learn more about becoming a watershed ambassador or getting involved? Do you take volunteers out with you?
Yeah, that's a great question. So you can actually visit our website, which you'll see here on the screen. Even if you just Google NJ WAP, it should come up. And we have a tab on our website that specifically gives you directions on how to apply to become a watershed ambassador. I think they're actually opening up recruitment a little early this year, so you might be able to start applying already. We do work a lot with volunteers, so if you're interested in volunteering for stream assessments, each ambassador hosts environmental stewardship trainings, which is kind of what this was meant to be. Unfortunately, right now we can't go outside, but hopefully in the future you'll be able to do one of these trainings outdoors. We also do partnership projects, so those could be anything from a rain barrel building workshop, a tree planting, a cleanup, and we love to have tons of volunteers at those events. So on our website, you can also find out what watershed you live in and who your watershed ambassador is. And then you can always contact them directly, and we're always happy to hear from community members.
Awesome. So another question is, when will live sampling resume?
That's a really... I'm sorry?
Field work.
Field work, yes. That's a really good question. We're still waiting on approval to be able to go back out in the fields, hopefully sometime in the beginning of July. Unfortunately, right now, I don't think we're able to take any volunteers out with us, just to be able to keep group sizes down and maintain social distancing. But hopefully we'll be out in the field soon, and hopefully sometime during the next term we'll be able to get more of the public involved. It's always more fun to do the sorting and all the assessments in the stream.
Definitely, that's my favorite part. If anybody that's in this webinar wants to get on the Sourland Conservancy's list for volunteers, I know some of the people in here, hi Donna, have done stream assessments with us before, and we would love to get you on our list so when we're able to go out and do some sampling, we can let you know. One thing that we have done in the past has been to hook volunteers up with the watershed ambassadors in the Sourland Mountain region. Like Anjali had said before, there's 3 different ambassadors. So we work with them to host trainings like the one that Anjali has just given, with the 2-part indoor and outdoor, except right now, obviously we can't do the outdoor part together, but then we match up volunteers with watershed ambassadors to go and get their feet wet and practice some sampling. So you can email me at info@sourland.org or at cklaube@sourland.org. And we always email out information about opportunities to volunteer, whether it's stream monitoring or other type of environmental stewardship. So does anybody have any more questions for Anjali? Don't be shy.
I love answering questions.
I don't, do you work on the Millstone Raritan River as well?
I personally do not. I believe that would be WMA 8, our ambassador Shay. So if you're in that area, I would definitely check out the website, and her contact information should be up there if you're interested in anything in that area.
Awesome, Anjali. Thank you so much. I really enjoyed your presentation. You're a very good speaker. It was very fun chatting with you. And I encourage anybody that's here to reach out to Anjali or to me if you want to learn more about stream monitoring and get involved. I really appreciate your time, Anjali, and for doing this for us.
Yeah, of course. Thank you so much. Like I said, this is one of my favorite presentations to give, so I'm always happy to do it. If any of you think of any questions about stream monitoring, the program, anything like that, again, you can email me. My term finishes end of July, so there might not be an ambassador for most of August and part of September. So if you email the ambassador email, then you might not get a response. Just a heads up about that, but they should be getting back to you probably mid-September. And you can also connect with us on Facebook because we've been serving from home. We've been putting out a lot of great educational materials, so you can always learn and keep updated with us on there. But thank you all so much again.
All right, great. Thank you so much, everyone. Take care.